All right, so we're going to look at now converting from standard form to vertex form by completing the square. So the directions will specifically ask you to use completing the square as your method for doing this. And if you think back to completing the square, what we used to do is in the last unit is we were solving for the roots. We were solving for x. Here we're not solving. So what's different is you don't have it set equal to 0, you have it set equal to y. And that's what's going to change things a little bit, but the steps are almost the same. So what the first thing you're going to do is, if you remember from completing the square, is that your c value has to move to the other side. So you have to subtract 32. Now, in the last unit, you had a 0. So it was just negative 32. Here, you don't have a 0. You have a y. So it's going to be y minus 32 equals x squared plus 12x. Then you take half of the b value and square it. If you remember, the b value is the 12. You're going to take half of b and square it. That's the part where you complete the square. So 6 squared is 36. And if you recall, this number gets added to both sides. Only now you have y that you're like carrying along with you, because this is a function. This is not, we're not solving for roots. We're just converting this function. So I'm going to bring down the y. I'm just going to keep taking it along with me. And it'll be y, and then negative 32 plus 36 is plus 4. So y plus 4 equals x squared plus 12x plus 36, because you can't really add those. Now whatever is in here is always going to be a perfect square trinomial, just like it was in the last unit. So you rewrite that as a binomial squared. So if you remember, you look at the middle number and the last number. 12 and 36, a certain number should come to mind. 6 plus 6 is 12, and 6 times 6 is 36. So it would be x plus 6 in the parentheses squared. And now it's going to change from what we did in the last unit, because now we're not solving for anything. So you are not taking the square root. You are not isolating x. Instead, you have to remind yourself here that our goal is to isolate y, because you need to just turn this into a function, y equals, and you're trying to get this into vertex form. So all you have to do is subtract the 4, and you're done. Y equals x plus 6 squared minus 4. That is now the same parabola, the same function, but written in vertex form. And it allows you to see the vertex coordinates. So the vertex I could see, because it's a shift. Remember yesterday, it's a shift 6 units to the left and 4 units down. So my vertex is going to be at negative, oh, no x there, sorry. My vertex is going to be at negative 6, comma, negative 4. Okay, they don't always ask you to state the vertex, but they just ask you to write the equation. All right, we'll do one more. You could try this one on your own maybe and pause me. We'll try one more, and you'll have one of these for homework on your worksheet. So in the next example, I am going to first move my c value over. I'm going to subtract 5. I have y minus 5 equals x squared minus 6x. I'm going to, so now we're going to take the b value. We're going to take half of the b value and square it. So I'm going to take the negative 6 divided by 2 and square it. So that's negative 3 squared is 9. So I'm going to be adding 9 to both sides. I now have y minus 5, I'm sorry, y plus 4. Okay, y plus 4, because negative 5 positive 9 is positive 4, equals x squared minus 6x plus 9. Whatever you get here will always be a perfect square trinomial. You now have to express that as a binomial squared and bring down the y plus 4. So you are going to have, if you look at the numbers, 6 makes you think of 3 plus 3, and 9 makes you think of 3 times 3. But this is a minus, so it'll be x minus 3 squared. And then you have to just isolate y. So all you do to isolate y is subtract the 4, and you're done. Y equals x minus 3 squared minus 4. That's vertex form. I could see here from the equation that the coordinates of the vertex are, if somebody asks me, you don't always have to do this, but the coordinates of the vertex are +3, because remember this was a shift to the right 3 units, and -4, because it's a shift down 4. So you could see how this ties into yesterday's lesson, which was translations of the parent function, and why I skipped this from your quadratics unit, because it was such a heavy unit. All right, have a good day, everybody.